We can review September 24th. We took a deep dive into functions. We've covered function concepts. I think we started talking about variable scope, static variables, default arguments, function overloading, and how functions enable code reuse. I want to make sure students understand variable scope, meaning how long does a variable live in our code and when can we use it? How can we access those variables? For example, I created this program that has a global variable, meaning it's declared outside main. So this is global scope. Num equals 5. We are able to display it. Our program doesn't error out because when our program is running, it knows that it can't find num here before it's declared as a main num. So then it goes outside of main and looks for it in the global variable memory. It finds it, it displays it. We create num with value 10. We call cout to display num. Our program, when it's running, knows that num is created in main. It displays the value 10. And then we call function scope, where we create another variable num with value 20. 3 different variables. If we look at memory, when main is loaded, num is created, but by that time, num5 is in memory too. When we call function scope in main, meaning when this statement executes, function scope, this is loaded onto memory, and now we have 1, 2, 3 different variable nums in 3 different memory addresses. Okay, so it is important to understand that we cannot access the function scope num in main before or after. If we try to access num, we will be accessing this num. If we try to access num before we declare num in main, we are accessing the num in global scope. And if we try to access a num in function scope, then we will be accessing this num right here. Okay, that is what I want to make sure students understand and carry on to their next lectures and homeworks. Okay, so a static variable persists, meaning it keeps its value. If we call a function 10 times, in this case, CNT will only be created 1 time. However, if we add 1 to it each time, we will eventually get the value 9 or 10, depending if we start with 0 or 1 as its initial value. Default arguments, we can assign a default value to function parameters like this. And then at that time, we do not have to call the function getTotal with, let me come here. I'm not sure if I used it in main. Yes, enter. So we have getWeeklyPay. Well, actually, let me go to the test case, right? Because I know that's where I used it. So then we go to the test case, examples, functions, and getTotal. We can call it without the 2 parameters. It fails the test case because of the rounding issue, right? However, notice we can call getTotal with 10. It uses the default parameter, which is, where are you? Come back to me. 0.0825. Thus, when we use it in our test case, it returns 8.25, right? Or we can override the default value by providing a different value. In this case, 0.0925, 0.925, right? So that's a concept of default parameters. We always have to make the default the farthest right parameter. Okay. And then next topic, function overloading, where we can create functions with the same return value, same name, however different parameters. And that concept is known as function overloading. Why do we use functions? Well, because they help us reuse code. We are already using it in our code. We create a library for examples or homeworks, like in this case. We can use that library in a test case. We can use it in main. Others can use our library, or if we have a Windows application in C++, we can also use that library, right? So that's a concept of, software reuse, or behind the scenes introduction to software engineering. We briefly talked about strings. So we know that strings are a sequence of characters. They live on the standard library. We can create strings like this. The examples are in the video for you all. More importantly, if we compare a string to a character data lives on the stack. A string, developers of the standard library have created the string with memory management capabilities where the data lives on the heap, and a reference to that data from the stack is executed. And the same thing for vectors, right? So vectors, list of three numbers, 1, 2, 3. Data is on the heap. A reference, meaning the first address here, assuming Y96, right? So Y96 points to the first element, and then there's code in the vector class that knows how to handle memory, knows how to go find this data, okay? Concepts that we will implement later in the semester. Okay, so I think that is so far what we've learned. And also do not forget the references, right? So a reference means we can modify an incoming variable, in this case int2 or string. Const reference, like this one at the end, means we have access to it for speed, but we cannot modify it, so it's read-only. That same thing applies for the string. Okay, so I think those are the highlights for this week, and that's it. Thank you.